So for problem number 4, what you're going to do is, so we have a wedge problem, and they give you all this information. You're going to have to sort through it. But they did give you a drawing that says, for the wedge shown alongside, given the angle between EA and ED. So EA, here's EA, and here's ED. That angle is 50 degrees. That's going to come in handy. And then, let's see, we are given that this angle here is 20, right? And then we are given that this distance back here is 500 centimeters. And so this is 500 centimeters. We want to find the angle between, well, let's find the length AE first. This is what we want to find. Okay? So I'm going to draw some triangles, fill them in. Here is a triangle. Here is another triangle. And let's take a look at the yellow one first. What is the angle at F? 90. Yep. Look at the blue triangle. What's the angle at D? 90. Yep. Yeah, Eli? Lunch. During lunch you can. Yeah. So you have the blue triangle, and you have those 90s. That helps a lot. Okay, so I'm going to draw those. Here is AE, and here is E, F, and D. So just fill in what you know. This will make sense. Now this is 20. This is 500, and here is what we're looking for, Z. Wouldn't it be great if we knew this X? Wouldn't that be great? That'd be great. And then this angle's 50. So with that said, the first step I would take is I would find ED. ED is going to, well, let's just do the sine of 20 is 500 over X. Okay, so X is 500 over the sine of 20. Okay. Now, what relationship is there between 50, X, and Z here? What relationship is that? Sine, cosine, or tangent? 50 adjacent hypotenuse. Cosine of 50 is X over Z. Good. So we're going to solve for Z. So I'm going to switch places here. X over the cosine of 50. So could you figure out X and could you figure out Z? Yeah, I think you could. Now it says, what is the angle AEB? So with this one, we have yet another triangle to fill in, a green one here, and this triangle okay, this triangle has, oh, what's the angle at B going to be, do you think? What's this angle at B going to be? 90, yep. So here you go. This angle down here? I don't think so. I think it'll be less because this is pulled off to the side here. It's a little tricky to visualize, but it'll make sense with the lab today. So then this angle is 90 at B. E, I don't know. I know this is 500 still. And what was that? D at the top? No. What is that? A at the top. We're trying to find this angle here. This is the question mark. Do I know anything else? AE is my answer from the first part, Z. So if you took the sine of angle AEB, I'm going to get 500 over whatever I get for Z. So that inverse sine of 500 over whatever Z turns out to be is going to be A, B, and F. So while we're at it, we're going to do 1B. And this one has a little tricky part to it, and I think I mentioned it yesterday, is you need to bisect this here. You need to split this in half, and you're going to figure out the angle here to here. That's the angle you're going to be finding. So the triangle I'm going to look at is going to be FC, and let's just call this one, do you mind if I call it G? G is good enough. I know this is 6. I know this is 4, and this is 4. What will the diagonal be? What will this length here be? 4 square root of 2. Do you agree with that? So what do you think half of it's going to be? 2 square root of 2. And so it says, find the angle there. So this is theta that we're looking for. And what relationship is there between theta, 6, and 2 root of 2? Tangent, right? Tangent of theta is going to be 6 over 2 root of 2. And then you're going to do the inverse tangent of that to get 3 over the square root of 2. And then you'll get that angle.